So here's problem number 47 from section, not 4.7, rather from section 3.6. All right. So we've got this parametric equation, which gives us a curve, and they want us to specifically find the tangent line to that curve when time is equal to pi over 3. Our plan of attack is to get a point first, then a slope, and then put it together in the equation. So here we go. First of all, what's my point? My point is going to be the value of x at pi over 3 and the value of y at pi over 3. So when I put pi over 3 in for my two places of t, I get pi over 3 minus the sine of pi over 3. And when I put it in for y, I get 1 minus the cosine of pi over 3. So for my x value, I get pi over 3, and the sine of pi over 3, let me draw my reference triangle. It's 1 to square root of 3. The pi over 3 angle is there, and sine is opposite over hypotenuse, so that's going to be minus root 3 over 2. There's my x value at pi over 3. Over here, for my y value, I've got 1 minus, and I need the cosine of pi over 3. That's the adjacent over the hypotenuse, and that's 1/2. So, what is my point when everything's said and done? It is pi over 3 minus root 3 over 2, comma, 1/2. So I got part of the problem done. I got the point part of the problem done. My next goal is to find the slope. And before I can find the slope, I need to find the derivative. So let's go ahead and let's find the derivative, dy dx. Now, in parametrics, the derivative dy dx is found by taking the derivative dy dt and dividing it by the derivative dx dt. So we look at our y value and we say, what is the derivative of y with respect to t? Well, the derivative of 1 is 0. The derivative of negative cosine is sine of t. Now we look at our x equation and say, what is the derivative of x with respect to t? The derivative of t is 1. The derivative of negative sine is negative cosine. So there's my derivative dy dx. Let's parlay that into what the slope is going to be. The slope is equal to dy dx when t is equal to pi over 3, which is going to be the sine of pi over 3 divided by 1 minus the cosine of pi over 3. Sine of pi over 3, again, is root 3 over 2. The cosine of pi over 3 is 1/2. So I've got root 3 over 2 divided by 1/2. Which is equal to root 3 over 2 multiplied by the reciprocal of 1/2, which is 2. Which means those two cancel. So I am going to get a slope of root 3. And now we're ready to put all the pieces together for the tangent line. The tangent line, therefore, is y times the slope of root 3 times the quantity x minus, and what's x's value? Minus the quantity root 3 minus, sorry, pi over 3 minus root 3 over 2, double close, and then plus 1/2. If I distribute this, as the book tends to do, well, let's distribute this through here first. If I distribute this, I get x, sorry, I don't get x. I get root 3x minus pi root 3 over 3 plus 3 over 2
Mr. Fedor,
plus 1/2. Did I make a mistake?
I think it's minus, because when you did the point right there.
There's a minus there, but I distribute the negative sign
okay.
through those 2 points, or through those 2 terms.
Right.
All right? And that ends up being root 3x minus pi root 3 over 3 plus 2. That's what I think the answer is. Well, but do we have proof? Let's put it into the grapher and see if we get a thing that looks like a curve and its tangent line. Let me go into parametric mode. Let's go into y equals, so we can put our equations in. T minus sine t for x, and then 1 minus cosine t for y. And then I'm going to want to put in my equation for the line. I'm going to force x to equal t, and then y is going to end up being root 3 times t minus pi times root 3. Whoops. Got to get used to this new way of doing things. Pi times root 3 divided by 3, and then plus, over here, plus 2. So let's give this a try. And let's see what we get. How about zoom standard? Let's see. There's our curve, and there's a tangent line. Let's back up a little bit, and let's make t go from, let's say, negative 9 to 9. And look at the graph again and see if it, so there's our parametric curve. It seems to be like a little hoppy thing. And then there's my tangent line. And does it look like the tangent line and that curve touch? And let's just double check this. When t is pi over 3, it says that I'm at 0.181 and y is 5. And then let me go to the other curve and then do the same thing. Second pi over 3. And those do not look like the same values. Now, why would they be the same values? It wouldn't be the same value. I need to know what is it when is it the same value when t has the same its old value? What was it? What was t's value?
T's original
Pi over 3 minus root 3 root 3 over 2. Now does it have the same values? Yeah. So now I'm on the line curve, and I'm at the same. So I have it at the same point. It looks like it's got the same slope. So I think we've nailed that one.